a greater rate of a cooling occur if there's a greater temperature change during a same period of a time. Like if the temperature change is greater, it means the rate of a cooling is higher. We have a lid, hot water, thermometer, clamp. Thermometer in figure 3.2 shows a temperature, room temperature. What is the room temperature? You can use a screen annotation to complete the room temperature. So room temperature, as you can see, it's about 23, 21, 24, 25 in this range. A student pours 200 cm cube of a hot water into a beaker. She records a temperature theta of a hot water at time t is equals to 0. She immediately start the stopwatch. She continued to record the time and temperature for every 30-second interval. And you can see the tables are there. One is for beaker, another one is for can. The student repeat the procedure using a metal can which is painted matte black. The readings are shown. Complete the column heading in table 3.1 and 3.2. Complete the column headings, the units. Yeah, that's good. Then look carefully at the temperature readings and we have to take the statement. So if we want to investigate the rate of cooling 94 to 89, what is the temperature change? And 93 to 87, what is the temperature change? So 94 to 89, that is a 5-degree change in temperature. 93 to 87, that is about 6-degree change in temperature. So which box I should tick when I'm comparing the rate of cooling? It's not a too big difference. One for a beaker, it changes by 5 degrees, but for a can, it changes by 6 degrees. So what should be the right option? So water in the beaker is having a smaller rate of a cooling than in a can. But I can also say it is, if you check the statement, the third box is more appropriate. Why third box is appropriate? Because this is 5 degrees, this is 6 degrees. Like there's not much significant differences there. If say this was a 5 degree and this was say 16 degree, then they have a significant difference. That's why option C is the more appropriate, as like the third box is more appropriate as compared to a second one. Then justify your conclusion by reference to reading. You'll mention for a beaker, it changes the temperature by 5, whereas can changes by 6, so which are approximately equal. In part C, a student in another school carry out the experiment and report that the rate of the cooling of a water in a can is different from rate of a cooling of a water in a beaker. He planned to change the experiment to find whether this difference in rate of a cooling is caused by the color or the metal can be better conductor. So because the rate of a cooling can be affected by the color as well as metals are conductor, so it might be due to the metal. So suggest 2 suitable changes to the apparatus that student could make. So what student can make, he can use a black painted beaker, like, because what student is investigating how a beaker and a can affect the rate of the cooling. But the can is a matte black. So what, for a fair comparison, what students should do, students should have a beaker also as a matte black. So because can is a matte black color, student want to investigate only how a beaker and a can affect the rate of the cooling. So he want to keep other parameters same. So how he can keep other parameters same? You can keep the other parameters same by using both of them as matte black. So use beaker or a matte black beaker. Then the metal of the can being better conductor than the material of the beaker. So what else he can do? Like either he can use a matte black beaker or he can use a shiny can, because if the beaker is shiny, the can should also be shiny. If the beaker is matte black, the can should also be matte black. So either use a matte black beaker or either use a shiny can, so that the results will be more accurate. Suggest two variables that you should control for the fair comparison. For a fair comparison, the water inside the beaker or the can should have same initial temperature, or amount of the water should be same, or the room temperature should also be same, or the lab temperature. Room temperature should be same, as well as the amount of the water used for both can and the beaker should be same. One precaution for accurate measurement, so we should look perpendicular. We should avoid parallax error. By looking perpendicular, or the thermometer bulb should not touch the base. So these are the precautionary measures we should take for this rate of cooling experiment.